We are using the device. Okay. వినబడతాయి వాయిస్ వినబడతాయి.
Good morning, ma'am.
Good morning. Who is there?
Yeah, I'm Narmada.
Narmada. Just show me your face.
Yes.
Hi. Hi.
Ma'am.
Hi.
Good morning, ma'am. I'm also session coordinator along with Narmada. My name is Amina.
Amina, yeah. I think I have seen you before.
Yes, ma'am. We have met.
Yeah. I remember your face.
Thank you. Shall we start, ma'am?
Yeah, no problem. We'll start because I'll have to leave again by 10:45 or so.
Okay.
Vijayalakshmi madam is there?
Yeah, ma'am will join, I think. No, she didn't.
Students are ready?
Yeah, 18 students, 16 members joined, ma'am.
So the list what you have given, it is accordingly we are going to
Yeah.
see
I'll
that,
call accordingly.
isn't it?
Yes, ma'am.
So first one is Y Kumari.
Yeah, first, yeah, shall we wait for Vijayalakshmi ma'am to join or shall we start, ma'am?
No, we'll just wait. Let her start the program because she being the convener,
Yeah,
it will be better. Ask her to join immediately so that we'll not waste much of time. Okay?
sure, ma'am. I will call her.
Yeah.
So that was replaced by.
Good morning, ma'am.
Good morning. Hi, Vijayalakshmi.
How are you, ma'am?
I'm good. How about you?
Thank you, ma'am. Thank you so much. I'm fine. It was a wonderful experience to me the other day when I came to your university.
Thank you
I
so
feel
much.
like I came back to my second home.
Yeah.
Yeah,
So
good morning,
from now
ma'am.
onwards, we'll be in touch, regular touch. Okay, Vijayalakshmi?
Yes, ma'am. Sure,
Yeah,
ma'am.
Good
We'll
morning,
start.
one and all. Yeah,
Ma'am, shall we start, ma'am?
yeah.
Yeah.
Yeah, all
Yeah.
the participants, please be ready for giving the presentations and all. Yeah, now I will take the chance to introduce our evaluator. Yeah, good morning, one and all present here. I'm Narmada, chemistry faculty from University College of Women's Koti. I'm grateful to introduce today's technical session evaluator, Professor Girija Mankatar ma'am from Palamur University, Mabuna district. Okay, and ma'am is working as a professor and chairman board of studies in the Department of Chemistry, Palamur University. Ma'am got best teacher award for the year of 2020 from the government of Telangana, and she also Executive Council member for Palamur University, and she served various administrative posts like from past 13 years as a registrar, controller of examiner, and joint director, academic audit cell, and head department of chemistry and head department of pharmacy, University Ladies Hostel, warden and all. And ma'am has 29 years of extensive postgraduate teaching experience in organic chemistry. And her research topics are synthesis of nanomaterials and their applications, and characterization synthesis of biologically important complex molecules. And she has 18 years of research experience and published several articles, research, and academic books. And ma'am also served as a member of editorial board of international journals. And she also the member of ACT, that is Association of Chemistry Teachers, and ICC, Indian Council of Chemistry, and annual member of ACS, American Chemical Society, and Institute of Engineering and Research publications. Thank you, ma'am. You're on behalf of the participants and teachers, faculty, we are welcoming you. Let us start the session, ma'am.
Yeah, thank you.
First,
Thank you, Narmada.
I invite the first presenter, oral presenter number 49, Y. Kumari, to please share the screen. Y. Kumari, oral presenter number 49.
Let them report to you, ma'am. Amina, ma'am, did they report to you, all of them?
yeah, almost she
Yes,
joined,
ma'am. They are
ma'am.
here, ma'am.
Kumari joined.
They have
ma'am.
joined.
If they are not ready, we'll go to the next one, ma'am.
Yeah,
We have
next.
the next presenter.
Yeah, next is Srivalli, ma'am. She will join afterwards, she said, ma'am. Next presenter 51, Satish Kumar. Be ready, please. P. Satish Kumar, third presenter.
Good morning, madam.
Yeah, good morning. Yeah, can you start presentation, sir?
Yeah, sure. Thank you.
Okay.
Madam, is my screen visible?
Yeah, your screen is visible, but your voice is not audible.
Madam, is it okay now?
Yeah, it's visible. It's okay.
Thank you, madam. Good morning, one and all. The respected session coordinator, Girija Madam Garu, Narmada Madam Garu, Amina Hussain Madam Garu, Vijay Kumar Madam Garu. I'm very happy to be associated to present this presentation. Sorry for this. Today's topic is conventional and green synthesis of azomethane derivatives of some biologically important aldehydes. And my name is P. Satish Kumar, research scholar from Osmania University, under able guidance of Dr. Alia Begum Madam. CH double bond N, where R referred to any alkyl or aryl group, is referred as azomethane, which is found to be ubiquitous in many fields of sciences and human life. These groups are inviting and interesting because of their simple synthetic protocols, their versatile character, and diverse range of applications has been constantly attracting many researchers among the world for designing different types of azomethane skeletons and various synthetic methodologies. By incorporating various types of functionalized carbocyclic and or heterocyclic moieties of aromatic and non-aromatic skeletons has been shown to be a promising pharmacological strategy to enhance the biological activity of different kinds of azomethane compounds. In the present study, some of the biologically important aldehydes and some primary amines, especially one of the anti-diabetic drug which contain primary amine skeleton have been selected for the design of azomethane skeleton in conventional as well as microwave method in the presence of both conventional acids like acetic acid as well as natural acids like citric acid. The use of ionic liquids are also extended in my work, which is showed in the latter slides. Madam, this is the reaction scheme which I was proposed. The first one is indole skeletons, and the indole skeleton is being treated with some biologically important amine, especially one of the anti-diabetic drug. The reaction expected in between these two in the presence of acetic acid, which is a conventional acid, the time taken for the condensation is approximately 2 hours, and the reaction regularly monitored by TLC. The expected yield of the reaction is 67%. Whereas the same synthesis have been shifted to microwave method from conventional. The completion of reaction is in 5 minutes, and the expected yield is 75%. Whereas the microwave method, I would like to introduce lemon acid instead of acetic acid. Sorry, madam, it is nearly 4 minutes of time, not 2 hours. I am extremely sorry. And the expected yield of the reaction is 78%. The same theme are also used by same reaction also performed with the help of ionic liquids, especially imidazole skeletons used by me, and a performed conventional method, ordinary reflex for 1 hour 20 minutes, and the expected yield is 72%. In all the schemes, the produced product is in light yellowish color, pale yellow color. And this is what the NMR spectral data which I got from CFR Usmania University, and these are the values of proton NMR spectrum as well as C13 NMR spectrum. The peak at 9.05 ppm singlet stands for azomethane proton. That means the proton of aldehyde.
Excuse me, Satish sir. Please try to conclude fast, sir.
Yeah. So these are the references used for my work. And final conclusion from my research work, the result of the study suggested that microwave-assisted synthesis in the presence of lemon juice lead to higher yields within very short reaction times compared to conventional method, which is one of the green principle that is designed for energy efficiency. The prepared compounds are subjected for spectroscopic studies like NMR, proton NMR, C13 NMR, and IR, which provided invaluable and complementary data in the present study to understand the structure of the prepared compound. Finally, I would like to express my special thanks of gratitude to Dr. Vijayalakshmi Madam Garu, Head Department of Chemistry, Department of University College for Women, Hyderabad, for organizing and providing this opportunity that has equipped me with an immeasurable amount of experience. This is to convey my deepest sense of thankfulness to Dr. V. Shachikala Madam, convener, and other organizing committee members of today's virtual internet conference for providing time space to explore my presentation. I'm extremely grateful to my research supervisor, Dr. Alia Begum Madam Garu, who gave me the golden opportunity to do this wonderful project on the topic conventional and green synthesis of azomethane derivatives of biologically important aldehydes, without whom I would have been unable to present this presentation. Finally, my thanks goes to all the people who have supported me to complete the presentation directly and indirectly. And I would like to add my special thanks to Girija Madam, who is one of my teacher in my postgraduate second year. Thank you.
Thank you, Satish sir. Any questions, Girija ma'am, or from the audience?
Yeah, audience, sir, ma'am, any questions?
Yeah, I think, see, Satish, there's one suggestion.
Yes.
See, you could have given more importance to your presentation rather than introduction, isn't it?
Yes, ma'am.
Thank you, ma'am.
Next, yeah, we'll
Yeah.
proceed.
Yeah, oral presenter 49, the Y Kumari. If she's there, please start presenting.
Satish sir, you can stop share, sir. Thank you.
Y Kumari, please start presenting. If you're joined it.
Good morning, everyone.
Yeah, good morning.
Good morning.
You please
I'm
start.
by Kumari. Starting, madam.
Kumari, is she Kumari?
Yes, yes, ma'am.
First
Please start, ma'am.
Good morning, everyone.
Yes.
I am by Kumari, research scholar, organic chemistry, Department of Organic Chemistry and FTW, under the guidance of Dr. V. Siddhaya, Andhra University, Visakhapatnam. Today my topic is a fossil synthesis of N dimethyl 2 substituted 1H indole 1 carboxymides via cross dehydrogenative coupling of 2 substituted indoles and formamides. Introduction, madam. Carboxymide derivatives are important heterocycles and recognized as a privileged scaffolds due to its various applications in pharmaceutical chemistry and natural products. And a heterocyclic moieties having N carboxymide group shows a wide range of biological activities like insecticidal, antibacterial, anti-cancer, etc. They have also been used as a pesticides. For example, indoxacarb is a commercially available pesticide against Lepidoptera larva. Therefore, it is in demand to develop a new protocol for the construction of 2 substituted indole-based and carboxymides. These are some biological important molecules contains carboxymide moieties. So this is the carboxymide moieties. This is indoxacarb, which is a commercially available pesticides. These are some biologically active molecules having this carboxymide group. My present work here, we report a facile method for the synthesis of indole-based carboxymides via formation of CN bond by cross-dehydrogenative coupling of 2 substituted indoles and formamides in presence of copper, in the presence of a catalyst copper and oxidated TBHP at 100 degrees centigrade for 6 hours. This is my optimization table. So far I have done. So first I have started the reaction by taking 2-phenyl indole and formamide in presence of copper chloride and TBHP, 3 mole percentage of a catalyst in solvent DMF and temperature is 50 degrees. So I observed the yield of the product is 37%. When I increase the temperature from 50 to 100 degrees, there is an increase in the yield of the product. Like this, I got 80% yield when I increase the temperature up to 100 degrees. When I increase the temperature greater than 100 degrees, there is a decrease in the product. And also when I screened out different catalysts, here for example copper bromide, with copper bromide I have got 65% of yield, and with copper estate I got 0%. There is no product formation. So this is my optimization table. This is the optimization table. When I increase the catalytic percentage, for example 3 mole percentage to 5 mole percentage, there is no improvement of the yield of the product. When I decrease the catalyst percentage from 3 to 2, there is a decrease in the yield of the product. This is about optimization table. These are the derivatives so far I have done. So these are the derivatives, 20 derivatives I have done. Next, plausible mechanism. The initial step involved the formation of the complex 4. This is the complex 4 from 2-phenyl indoles. From 2-phenyl indoles, copper catalyst and oxidant to TBHP. Here complex formation takes place. On the other hand, here formation of 5 radical formation takes place. Formamide undergo radical cleavage in the presence of TBHP. Radical formation takes place. Finally, the desired product, this is my desired product, is formed between the coupling between 4 and 5. This is the plausible mechanism. Conclusion, herein we report a simple and efficient method for the simple synthesis of various carboxymides from easily available to substituted indoles and formamides in the presence of copper catalyst and TBHP oxidant at 100 degrees temperature for 6 hours. Thank you, madam. Thank you for everyone. Thank you for organization team, madam. Thank you.
Thank you, Ms. Kumari. Open for questions from audience.
Kumari, and do you know the full form of TBHP?
Madam,
What is-
TBHP, madam. Tertiary butyl hydroperoxide, madam.
What is the purpose of adding this?
This is an oxidant, madam. In the presence of oxidant only, here
Yeah,
oxidation
it's a
takes place.
radical
Removal of,
initiator.
yes,
Radical
madam, and
initiator.
also used as an oxidant, madam.
Yeah.
So here removal of 2 hydrogens takes place. No, it is an oxidation reaction, nothing but oxidation, removal of hydrogen, no, madam. In presence of TBHP, this reaction is moving.
Okay. Have you published this work?
Not this work, madam, but related type of work is published.
Because you said you have prepared 40 compounds.
Is it your work? Sorry.
Yes, madam, it is my work. Still doing, madam.
See, because already you said already you have prepared 40 molecules, isn't it?
Not 40, madam. 20, madam.
20.
Yes,
Yeah,
madam.
20 is also a big number. It's not a small number.
Yes, madam. Really, this type
What
of
is that
work
which is
is
stopping
published,
you?
madam.
What is that which is stopping you from publishing?
What, madam?
What is that which is stopping you from publishing?
Publishing, madam. I have to do more examples, madam, because I have to publish in more paper which is having more impact factor. That's data, madam.
So you wanted
and
to send it to
also,
a big paper.
and also I want data, madam.
Okay.
Waiting for data, madam.
Ma, how did you calculate the concentration of TBHP, Amma? Hello? Kumari, how did you calculate the concentration of TBHP?
Concentration of
TBHP.
TBHP.
mole percentage, madam.
Yeah, the oxidant which you have taken, how did you calculate that?
This one, madam. Using for a
What method you have used? What kind of titration you have used? Or what method you
not
have used?
titrations, madam.
What method you have used for calculating the concentration of TBHP you are taking in the medium?
TBHP
You
is
said three
commercially available,
equivalents, right?
madam. 3 more percentage, madam. In our lab, we are using that calculation table. We are taking depending on
No,
mole
you're not getting
percentage.
the point.
moles.
No. You're not understanding my question. Okay. No problem. So the mechanism that you are suggesting is it's not free radical?
It's free radical, madam.
It's free radical mechanism.
Then how
Yes,
are you
actually.
following up the intermediates, Amma?
Oh, madam. This one, madam.
I mean, what the characterization that you are using?
What is the technique that is? How did you characterize?
It is
The intermediates.
intermediates, madam. It is just a plausible mechanism, madam.
So you have not yet done the characterization?
No, madam. Still doing, madam.
Okay.
This is under the manuscript preparation, waiting for data also, madam. That's fine.
Okay.
Okay, madam.
Thank you, Ms. Kumari.
Thank you, madam.
Yeah, now I'll call oral presenter 52, that is Srilata, present the session.
Ms. Kumari, you can stop share and please mute yourself.
Ms. Srilata, yeah, please start presenting.
I request all the participants to please stick to the time duration of 5 minutes during your presentation.
Are you there, Ms. Srilata? You have joined, I think. Not responding. Yeah, you are joined with the phone, I think, ma'am. Yeah, Srilata, you can start presenting.
Yes, madam, but not share. Madam, I can't. My slides are can't show in my apps, madam.
Sita, what's the problem?
Some technical problem, madam.
Technical issue. Shall we move to other person?
Yes.
Yes,
Srilata,
madam.
you
Okay.
please send your slides to me on WhatsApp, and I will try to
Okay.
open it later on again.
Okay, madam.
We will
Okay,
move
madam.
to the next
Okay,
contestant.
okay, madam.
You have to stop sharing, Srilata. First you stop share and then you can share. You can send to me. Srilata, you have to stop sharing first. You stop sharing, you send it to me, we'll call you back again. Okay.
Okay, madam.
Next contestant, OP53, Miss Priyal, please be ready.
Go to the next one. They're not ready. They're not reporting.
Miss Priyal. Okay. Oral presenter number 53, Dr. B. Naveen. Dr. B. Naveen, please unmute and let me know if you are here, sir. Okay, oral presenter number 54, Miss PSK Sanjana.
Yes, ma'am, I'm there.
Okay, Sanjana, please, you can start sharing your slides.
Yes, ma'am. Ma'am, is it visible?
Yes, it is visible.
Okay, can I start?
Yes, please.
Yes, please.
Good morning to one and all present here. Today, I'm going to present my paper on QSAR studies on HIV-1 protease, a battle against HIV using computational chemistry. The paper is authored by me under the guidance and co-authors, Dr. Radhika Vangala and Shrikant Sivan. So coming to the introduction of what we did, a new series of HIV-1 protease were designed incorporating stereochemically defined tetrahydrofuran tertiary amine acetamide P2 ligands. In order to maximize the binding site interactions in protease activity, various subsequent effects on tertiary amine P2 and phenyl sulfonamide P2 ligands were investigated. In this study, HIV-1 protease was combined with these ligands and QSAR and docking studies were performed. Now we can ask the question, why HIV-1 protease? It is because it is a widely exploited drug target for HIV and has a broad substrate recognition. The GAG and GAG polyproteins recognition is important for virion maturation. It is also an essential enzyme for viral infectivity. Now, because HIV is the world's most serious health issues, it is important to find a cure or treatment, and hence this work. Coming to the materials and methods, ChemSketch. Now, ChemSketch freeware was used for drawing structures of potent inhibitors of HIV-1 protease. Dataset collection, inhibitory concentrations of 37 compounds were changed into their PIC50 values. SMILES notation, 37 molecules, inhibitory activity was converted to SMILE notation. The data was further divided into training set and test set. Coming to descriptor calculation, we calculated the ADME properties of these compounds using PKCSM. Next, what we did was we developed a model using QSAR. Now, this was done by using the built QSAR software. A correlation analysis was carried out between the calculated descriptors and biological activity to comprehend the relationship between the two. Then we carried out multiple linear regression studies where we selected different descriptor combinations. We chose the best model depending upon the Pearson R value and the regression coefficient Q2. Then coming to next step, what we did was we calculated the predicted activity of the 10 test set molecules, the standard deviation values, the press values, and we calculated R square. Then this was followed by docking methodology. Now, the docking methodology involved the following steps. It involved the protein preparation, where HIV-1 protease was prepared using a preparation wizard of Schrödinger suite. Ligand preparation, the HIV-1 protease inhibitors were built in Schrödinger suite using the LickPrep module of OPLS3 force field. A grid was generated using the receptor grid generation of the same software. Finally, the ligand docking was done, where 37 ligand molecules were docked flexibly, generating several poses. Then we chose the best molecules depending upon the lowest dock score and the highest glide score, which can then be considered as possible lead molecules. Now, coming to results and discussion. So the first results are for 2D QSAR. When we carried out a correlation analysis for all the molecular properties and biological activity, the molecular properties that gave good correlation coefficient with biological activity were selected for the QSAR model generation. We chose a total of 10 out of the 15 descriptors to obtain a best fit. The choosing of these descriptors was on hidden trial method. From the equation that is given over here, it can be seen that the Pearson R value obtained was 0.942, while the regression coefficient Q2 was 0.701. Then model validation. The model validation was done for the test set, where the predictability and validity of the model was based on the active compounds that were judged based on the cross-validation coefficient that we obtained, which was 0.722. The model was seen to be validated as both the values of R2, R square and Q2 was about 0.7, where the difference between them is negligible, indicating that the model is 70% good. Then finally, before that, here we can see two graphs. One is the correlation analysis that we obtained from MLR. And the next graph is the scatter plot for experimental and predicted activities of the ligands, and they show a linear correlation. Then coming to docking. Docking was carried out for all 37 compounds. The dock scores obtained ranged from -11 to -7. Molecular 25E was seen to have the highest dock score, -11.262, showing a best fit between the ligand and the protein. Further, these were the other molecules which also showed the highest docking score. Finally, coming to conclusion, the combined studies of ligand-based drug design and structure-based drug design computational approach was applied to obtain the information for discovery of novel HIV-1 protease inhibitors. Now, this study can be further employed for downstream processing such as virtual screening, followed by potential clinical trials if efficacy is seen, and thus aid in a novel treatment for HIV. Thank you.
When was the paper published? Anjana?
Ma'am, the paper was not published. The reason why I'm attending this conference is because I wanted to submit my paper for publication.
Yes, I didn't get you.
Ma'am, the paper is not published yet. The reason I'm attending this conference is because I want to publish my paper. I want to give it for publication.
Yeah, that's all. Because you said I'm the author, first author, something like that. We're talking there
No,
initially.
ma'am, I just meant that this paper was done by me.
Yeah.
Yes,
Okay.
ma'am.
Thank you.
Nice
So
work,
much.
ma'am. Yeah.
Yeah, next,
We can call Srilata. I have her PPTs I can share. Srilata, are you there?
Yes, madam.
Okay, Srilata, I'm going to share your PPTs so you can start presenting. Yes, Srilata, you can start. Is it visible to everyone, the PPTs?
Okay, madam. I will.
Yes,
Okay.
madam, it is seen.
Okay.
Yes,
Srilata,
madam.
under whom you are doing, you have not mentioned that? You are a research scholar?
Alia Begum, madam.
Okay. You have to mention that, no? You can
No,
do the
madam.
work alone, right?
No, madam.
Okay.
My
Yeah, please
supervisor
continue.
is Alia Begum.
Okay, please continue, ma.
Okay, madam. Good morning to all my uh, teachers and officers.
You can just directly go to your work because you don't have time.
Okay, madam. My name is Srilata, research scholar. Today's my topic is green synthesis of nanoparticles, characterization and synthesis of nanoparticles using a green extract. Green synthesis has gained extensive attention as a reliable and sustainable process. This green synthesis eco-friendly process to because of increasing popularly are much needed to as result of worldwide big problems associated with the environmental contamination due to several industries used hazardous chemicals such as pharma industries and colleges and various types of industries. That's why nowadays we are using green chemistry methods. These methods useful for reduced or less hazardous chemicals, cost effective and without environment contamination. Nowadays, recently, some research scholars and some industrial areas using these methods preparation of organic compounds. In this green synthesis have some principles guide for chemist and chemical technologies developing in less hazardous chemicals. That's why I used for this silver nanoparticles preparation. Preparation of powder extract. 10 grams of fenugreek seed powder was mixed with a 100 ml deionized water solution was left into boil for 15 minutes on hot plate. Then Wattsman filter paper was then used for filtration for seed extraction. This seed extraction has containing some phytochemicals like flavonoids, functional groups like ketones and aldehydes and carboxylic such as some functional groups acts as a reducing agents. Green synthesis have nanoparticles has a some characters. Nanoparticles biosynthesis of silver nanoparticles. For the biosynthesis of silver nanoparticles, 1 mm silver nitrate is prepared. Prepared using silver nitrate and triple ionized water. 5 ml of fenugreek filtrate mixed with a 90 ml silver nitrate solution and left into incubate overnight. Then the solution can change color from light yellow to dark brown. Then I confirmed the metal nanoparticles is formed. The reaction mixer was centrifuged to remove the unreacted silver ions. Then that product I can use for characterization and applications of silver nanoparticles. UV spectra recorded during the synthesis of nanoparticles shows that absorption of maximum at 425 nanometers. Due to the color change of fenugreek seed extract with silver nanoparticles. Then I confirmed silver nanoparticles is formed. TEM analysis also I can apply. TEM images of silver nanoparticle shows the particles uniform distribution, shape and size. particles spherical with the diameter with the range from 10 to 50 nanometers. Then applications also I found in the silver nanoparticles. Antibacterial activity study of silver nanoparticles. Silver nanoparticles showed significant of antibacterial activity against all the pathogenic bacteria. And also, I can study antifungal activity study. The fenugreek seed extract were assigned for antifungal activity against the fusarium fungus. This biosynthesis, green synthesis main concept is nanoparticles main key role act as a in organic compound preparation in single step process. Less hazardous chemicals used and not contaminate to the environmental, cost effective and large production of nanoparticles by using nanoparticles. Then I can prepare the organic compounds, large production. Okay, thank you, madam.
Any questions?
Srilata, you could have shown your UV spectral details, the spectra and the TEM images. You have just given the data. You have just given the data, isn't it?
Okay. Oh, okay, madam.
You didn't show any of the slides showing the TEM images and then UV spectra and other things. It is just about the matter what you have written.
Okay, madam.
Yeah, I think there is a lot of work to do, Srilata,
Yeah.
right? Characterization
madam.
also, there is so much for you to do. Right. I
Okay,
think you have
madam.
just started.
Okay.
You just started working on this.
Yes, madam. I started, but little some
Okay.
work, madam.
No problem. Right. Okay.
Okay,
All the
madam.
best.
Okay, madam. Thank you, madam.
Thank you, Srilata.
Okay, madam. Thank you.
Yeah, the next presenter, oral presenter 55, Rajendri Kashyap.
Okay.
Hello, can you hear me?
Yeah, yes, ma'am.
Yeah, so today I'm here with a very interesting presentation, and my title is Deals Always, a thriller story of nature. I am a PhD scholar.
One second, I'm sorry to interrupt you. Your good name?
Rajnandini Kashyap.
Okay, 55.
Can I start?
Yeah.
Yeah. So,
You can start.
So I just want to brief about Diels-Alder reaction. It's basically a 4+2 cycloaddition reaction where we see that there is sharing of electrons between the diene and the dienophile. You can see over here. So there are two types of Diels-Alder reaction, basically the intra and intermolecular Diels-Alder reaction. Intramolecular Diels-Alder reactions are very easy to happen since the homo-LOMO gap is very close in between them. But the complexity increases when you have further complexity on the dienophile, and it is an intermolecular Diels-Alder reaction. And we know that it is an indispensable reaction that can happen for a chemist to take place in the lab, since it carry on with a very high thermal temperature. So we asked a question that like there are more than 400 natural products found in the nature which are outcome of intermolecular Diels-Alder reaction, but does the nature, so that for the last decade we had a speculation whether the nature knows the Diels-Alder reaction. Does it have any enzyme specific for a particular biosynthetic pathway of Diels-Alder reaction? So we went ahead and digged into the literature. I started my PhD in 2016, so we got to know have the natural Diels-Alder where we could find the idle proteins PYR4 and ABYU, where you can see that there is basically a lining of hydrophobic residues in the active site, and which traps the acyclic structure, and then it catalyzes the reaction. So there are two types of two proteins in the family, PYR4 and ABYU. There are also artificial Diels-Alder which dates back to some 100 years, and then this was a very famous reaction performed, pioneered by Hawk and Siegel group. So they generated artificial enzymes that can react, that can basically do the intermolecular Diels-Alder reaction, but the limitation was that it is an artificial enzyme, thus there is a product inhibition that happens, and also the stereoselectivity is also selected, and also this reaction happens only on a particular synthetic substrate. So we asked a question that there are so many natural products in the nature, so why can't we have the same concept what they have used in the study? Basically, they the basic realm of this Diels-Alder was that the enzyme basically brings down the HOMO and the LUMO gap of the reaction. Sorry, this is not happening. Yeah, so we asked the question that whether these enzymes, whether the natural enzymes, can we use them for synthetic substrates? As we have heard about the thalidomide disaster in the nature, so we took an approach where we have done the bioinformatic analysis. I took the ideal proteins ABYU and PYR4, and we basically sequenced them, and we know that there is a structural homology that happens in these two proteins, but there is no as such conservation of amino acids in the active site. And what we have observed is that basically it's lined with the hydrophobic residues in the active site, which leads to the reduction in the gap of HOMO-LUMO, and it catalyzes intramolecular Diels-Alder reaction. So what we did is basically we did the bioinformatic analysis. We took these two proteins as the ideal proteins. We took another two proteins by the bioinformatic analysis, where you can see the highlighted proteins. And then we took basically 4 natural proteins, out of which 2 were hypothetical proteins, which were just dumped in the database. And we generated these proteins in the lab, and we purified, crystallized, and then the stage came, a very interesting stage where I was very hopeful that we could find some intermolecular reaction happening with these proteins. And I hunted for several reactions basically, and then this was the gem Diels-Alder reaction in my gold field. And it was like so this reaction was used by the artificial enzymes, and this is an ideal intermolecular Diels-Alder reaction. There is no enzyme, natural enzyme, being shown to catalyze intermolecular Diels-Alder reaction. So I kept the reaction. I was so hopeful and to see whether there is a reaction happening. When I kept the reaction, I saw that. Pardon?
Please continue.
So, yeah. So when I kept the reaction, and then for my surprise, I could see the product being catalyzed by this enzyme, by 2 of the enzymes basically, and 2 enzymes were they also showed the reaction, but we were after that I was curious to know whether the reaction is, so basically we know that this reaction also happens in chemical conditions, but they operate at very high thermal temperatures of 110 degree under hazardous solvent conditions. And the background reaction, as you can see, it's a mixture of 4 stereoisomers, which I'll be talking ahead. And when I saw the reaction, it was to a surprise that with both of these enzymes, I could see 32-fold enhancement with ABNU, while 16-fold with PYR4 enzyme, where you can see the background reaction is very, very little. And then after this, as it's a mixture of, so in chemistry, there are possibilities of 8 stereoisomer formation with this reaction. But in principle, in chemistry, like in observation, we see that there are only 4 isomers, stereoisomers being formed. And when we basically did the chiral resolution for the reaction, we could see that in the control reaction, you can see all the 4 possible.
Excuse me, Rajnandini, sorry to interrupt. Please try to conclude.
Yes. So when we saw that in the background reaction, you could see all the 4 possible stereoisomers being formed. But when we see the ABNU and PYR4, they exclusively catalyze for the first time. This is the first evidence of any enzyme, of a natural enzyme catalyzing intermolecular Diels-Alder reaction, and that too forming energy unfavorable product, that is exostereoisomer. So you can see only the single peak in there, and that was a very fantastic results. And after that, what we did is basically the kinetic characterization, where we could see that it matches with this with the artificial deal-solved races. And so we also saw the structure. We could see the ligand density in the active site. We also did the site-directed mutagenesis of the protein. We could see that there is a difference in the stereoselectivity that we observe, and we further went ahead and increased the complexity of the dinophile. We could see that as we increase the complexity of the dinophile, the rate of the reaction falls down. So we published this study in Nature Communication Chemistry, and it is the first evidence of any natural enzyme catalyzing on synthetic Diels-Alder reaction, and it opens the realm for the industry to just give us some reaction, and we can just play around with the active site of the protein, and we can use it for the industrial purpose. Thank you so much.
Yeah, thank you, Ms. Kashyap.
Yes.
Yeah, now our next presenter is Dr. Srivalli ma'am from Koti Men's College. Yeah, she joined from Ayub sir's phone, it seems, laptop. It seems. Yeah, ma'am, please start presenting.
Yes, good afternoon, good morning to all.
Good morning,
my
ma'am.
video is. Am I? My video is sharing.
No, ma'am, up till now. We're not able to see anything.
One minute, ma'am. I think I'm having a network glitch.
We go to the next one, madam.
Please, yes, you go to the next one, ma'am. I'll just join. When I'm ready, I'll join, ma'am.
Yeah, Girija ma'am, you want to ask any questions to Rajnandini ma'am? I didn't ask you.
Yeah. I was actually looking at that reaction.
Yeah. You just ask any questions.
Maybe desktop like this one, sir.
Not an ask, but then, okay, ma'am, it's over now. I just wanted to ask her regarding the mechanism.
She's
Fine,
ready,
madam.
ma'am. She's ready, ma'am. You can ask her if you want.
Yeah.
Raj-
Hello.
Am I audible?
Yes, ma'am.
Hello.
Hello. Yes, ma'am.
It's okay. It's okay, madam. Let's go to the next person. Yeah.
Okay. All right. Yeah.
Okay, ma'am.
Okay, all the best, ma.
Yeah, Srivalli ma'am, are you ready, or shall we go to next person? Yeah, oral presenter 56, Revati Sundaramurthy. Are you ready, sir? Yeah, it's ma'am. Yeah, ma'am, you can start presenting.
It's visible, Ms. Murthy. Please unmute yourself. We are not able to hear you.
Am I audible now?
Yes,
Yeah.
you're audible. You can start, please.
So a great good morning to one and all. Myself, Revati Sundarmurthy. I'm working under Supervisor Dr. P. Muralidhar Reddy, sir. And my review topic is application of magnetic iron oxide particles in environmental, food, and forensic sciences. So I'm doing my PhD in Osmania University, Chemistry Department. And let me start. So we usually know the nanoparticles are of usually 1 to 100 nanometer size, but even 500 nanometer size are also considered nanoparticles. And we have different metal oxides, that is like silver and all, but usually we prefer iron oxide nanoparticles because of their typical properties. So yes. So why are we choosing iron oxide nanoparticles is because of their special properties other than the other metal oxides. That is, they have supermagnetism, they are biocompatible, and they can be absorbed. Apart from the nanoparticle properties, these are the other properties. So we have magmite, magnetite, and other things. But magnetite is more preferable because they have more ferromagnetism, so that they can, when the magnet is kept, they can be absorbed quickly. So synthesis, we have physical, chemical, biological, as there of other metals, and mostly they prefer co-precipitation, which is the common one. And during the synthesis process, the common limitation is that oxidation, where they form aggregations. So we need to put them under inert conditions, and then we have to coat them with different functional groups like silica, amines, and all, so that you can prevent them from aggregation. So in this part, I'll be talking about different applications. Firstly, I'll start with food applications. Like talking about food monitoring, you take MNPs that you coat with goat anti-mouse monoclonal antibodies, so that you can actually find out some typical drug that is synthesized in milk process that is usually given to increase the growth and vigor of the animal. So you have to remove, otherwise it is toxic. So the next part is the removal of food dyes, so which are commonly used like moisten, poncu, alora, red, and all. So even to remove we use this thing. Why are we using magnetic nanoparticles is that we coat it with some other functional group that you could isolate any other or detect any other particles, so that we can remove them easily with the help of magnet. And coming to food adulteration, we have a polydopamine MNPs, where they actually identify different species of meat. We have goat meat, we have pork, beef. So sometimes they actually give pork, beef because they are of less cost, but sometimes some people are allergic to that. So in order to identify those adulterations, this MNPs can also be used. So coming to the alkaloids, poppy seeds like cuscus, which have different alkaloids, like those seeds are harmless, but the other part of the plant is actually harmful. Sometimes they are mixed and given so that they start getting addicted. So even to detect those things, we use these MNPs. So coming to food pathogen, we have tryptamine functionalized MNPs, where they detect typical Salmonella typhimurium pathogen that usually causes food poisoning. And other thing is Echinobacter baumannii. This is other bacteria that is found in fresh foods like apple, strawberries, and all. So that even to detect these things, we use MNP coating with different like tryptamine and oleic acid and other things. So coming to the forensic applications, we see starting with illicit drugs. Some illegal drugs are very difficult to detect, like the synthetic, they are synthesized in such a way. So what they do, even for that, we use MNP and ketamine so that it is detected easily. And even cocaine, other methamphetamine is also detected. So coming to latent fingerprint, where to enhance, so in crime scene we get fingerprints that are actually to be deciphered. So in order to do that, they use MNP to enhance the visibility. So coming to biomolecules, we have biomolecules, we take cells. So usually in sexual assault cases, we come across sperm cells connected to epithelial cells. It is very difficult to remove them or isolate them. So for that also they use MNPs. So coated with immunomagnetic, coated with antibody anti-PH20. So coming to explosive detection. So in this, TATP is another explosive that is very hard to detect once it is exploded. So those vapors are vanished quickly. So even to detect those minute vapors, we use MNP coated with NN-dimethyl para phenylene diamine sensors. So like
Excuse me, Ms. Revati, please try to conclude.
Almost done, ma'am. Environment applications, you can see the extraction of heavy metals and dye, and even those things are removed. So usually heavy metals and dyes are seen in sewage waters, rivers, normal good sea rivers and all. To remove that also they use MNPs, and also to remove microplastics. Now this has become the common threat, where in blood also the microplastics are seen. So even to remove them we use the magnetic ion particles. So this is how they are actually removed from using magnets. So this is what I have to tell regarding the magnetic IONPs, and they have unique properties than the other metals. So of course, than the normal fields like medicine and all, even in fields, a special variety of fields like forensic and food also, they create more opportunities. So I thank my supervisor and head of the department and UGC for providing the facilities, and I thank all the audiences and faculty members for their patience listening. Thank you, ma'am. Any questions I can answer?
Yes. Thank you, Ms. Revati. Any questions from audience, from Granger, madam?
Well, I don't have any questions, ma'am. Maybe from if the participants are interested, they can ask.
Any questions from the participants, or should we move to the next participant?
We can move to the next participant, ma'am.
Okay, thank you, Ms. Revati. You can stop sharing. Thank you.
Thank you, ma'am.
Yeah, now the next participant is oral presenter 50, Srivalli, ma'am.
Good morning, everyone.
I have Srivalli ma'am's PPT. I'll share it. Ma'am, you can present.
Okay. Thank you, Amina.
Yes, ma'am. Is it visible, ma'am?
Yes. So my topic is impact of behaving practices on chemical compounds chemical compounds of honey, a comparative study. Here, honey is an edible substance deposited by gathering nectar and sugar from flowers and honeybees, who's pure and who purify and store into combs of jelly by their natural synthetic mode of synthesis. Honey has differences in taste, flavor, aroma, and color. Honey has difference in taste because of due to different sources. The importance of the importance of honey as a nutrient rich in energy and prebiotic compound as well as in disease treatment necessitates the identification of physiochemical parameters and quantitative parameters. In physiochemical parameters, we are having moisture content, pH, free acidity, sugar content. So for physiochemical properties, we are going to first the determination of moisture content. Moisture content is very important. It's carried out by oven drying method, and the results were obtained in less than 20%. Organically procured honey is having greater moisture content than the commercial brand. And we are coming to determination of viscosity. It is the amount they enter the water. It is the amount of water and the type of amount that is present, and it was determined by using Oswald viscometer. From this, C brand has a higher rate of viscosity compared to the other brands. Next slide. Next is quantitative for iron and calcium. Sorry, Amina, you're going fast, a bit slow.
This one, ma'am.
Before that.
Before that.
This one. Yes. Next is free acidity. Free acidity is related to deterioration of honey. It was created The next slide after this. Yes, the results indicate that organic honey had higher percentage of free acid, determination of ash content, where ash content is influenced by the conical origin, which in turn showcases the mineral kind. In this case, organic honey and brand C had higher percentage of ash content. Next is estimation of quantitative analysis of honey by using your quantitative analysis. Next is the estimation of ferrous by permanganate. Honey is a good source of iron, copper, manganese. When these are combined, they aid in the synthesis of hemoglobin. So here we are using mangometry. Ferric ion is oxidized to ferrous ion is oxidized to ion in presence of potassium. Permanganate in presence of sulfuric acid. Here A is having higher content of iron compared to the original honey. Next is estimation of calcium. Calcium is a calcium consuming honey provides calcium, is readily absorbed by and helps in to build bones, to build bone mass. So this was conducted by using your complexometry substrate reaction, and here the results show that Brandy is having more number of calcium ions compared to the organic. And the next is where we are coming for next slide. Next is determination of glucose by direct titration method, where he has a lower glycemic index than sugar, which means that it does not raises the blood levels. So here we had taken direct titration method. We have taken samples of honey and titrated it with a standard ferring solution, where the color changed from blue to red wine. Here the reducing sugar was observed high organic content. And once we are coming for the conclusion, honey, organic honey was higher in moisture content than branded honey. Total ash, iron, calcium content appears to be high in branded honeys. Organic honey appears to be high in reducing sugar and C. Organic honey has a high level of free acidity content, which may cause storage and stability issues over time. I thank the convener and organizer to have given me this opportunity to present my topic. And thank you everyone for listening to me patiently.
Thank you.
Thank you,
ma'am.
for sharing.
Thank you, madam. Welcome, ma'am. Any questions from the audience? Okay, if there are.
Mehta, madam, have you tested all these samples which are available in the market, ma'am? No. Ma'am, am I audible?
Hello.
Hello. Am I audible?
No, ma'am.
Hello.
Yes,
madam, can you hear me?
Yes, ma'am. Your question is audible. Ma'am wants to know if you have tested all the samples available in the market, all the brands which are available in the market.
I have tested all different 3 brands of sample and compared with the original sample of honey, which I have from Anantagiri of Victoria.
Okay, on what parameters you think which brand is the best one? I mean, the parameter as well as the best brand. Can you suggest based on your titrations?
Based on my titrating method, which is having brand which is having low moisture content, that is brand A, madam, which has low moisture content. Where if it is having low moisture, then it will have
is the brand A, ma'am? Can we know?
And viscosity also will be so brand A. Brand A will be more favored, madam.
Yeah, what is it, brand A, ma'am? Would you like to reveal that?
I relate, madam.
Okay, it's no problem. I think there is some audio problem from your side, ma'am. It's okay, ma'am. Right. Amina, ma'am, we can go to the next one.
Okay, ma'am.
Thank you, Srivalli, ma'am. Yeah, now the next participant, OP57, Saidulu Ganji. Mr. Saidulu Ganji can
yes,
start presentation.
Am I audible, ma'am?
Yeah, yes, sir.
Yeah, yes. My screen is visible, ma'am. Is it visible, ma'am?
Yeah, it's visible.
Very good morning to all. I'm Dr. G. Saidulu, Assistant Professor of Chemistry, JB Institute of Engineering and Technology. So first of all, I'd like to thank all the organizers for giving me this opportunity to present my work. So today's my topic is palladium SbSeOH is a green catalytic board for the production of hydrogen at room temperature in aqueous media. Yes. So here we have prepared some palladium nanocatalyst, palladium SbSeOH. Here we use for the production of hydrogen from hydrogen hydrate at room temperature in aqueous media. So before going to enter into this topic, I'd like to explain the importance of hydrogen. Nowadays, people are depending upon alternative fuel sources because of the diminishing of fossil fuels. Recently, we can see some recent paper clippings, and petrol and diesel prices are hiking because of the diminishing of fossil fuels. So, and also we can see one image here. See, he's Nitin Gadkari, Union Transport Minister, recently came to Parliament with hydrogen car. So nowadays people are using alternative energy sources. So hydrogen is one among them. So production of hydrogen is very important. So here in my presentation, so this is hydrogen car. Here, if you use hydrogen as a fuel, so zero emission means no byproducts are forming here. So yesterday in yesterday's talk, Professor Govardhan Mehta also mentioned this zero emission is required. And also Dr. Nitin Gadkari also mentioned that the future, green hydrogen is the future of India. Okay. So coming to my presentation, see here, graphically, because of the limited time period, I'm representing this graphically. See here, this is the green catalytic board. This is my catalyst. So I have prepared palladium SbSeOH catalyst. This we have used for the production of hydrogen from hydrogen hydrate at room temperature in aqueous media. And this in situ produced hydrogen we have used for the conversion of substituted nitroarenes to substituted aminoarenes. Okay. So here no need to use any external hydrogen. This in situ produced hydrogen only we are using for
excuse me, sir, we are not able to see the slides. So still we are on the first slide here.
Slides are not moving.
No, sir, they are not moving.
Yeah, it is in the first slide only.
They're moving on my system.
Yeah, now it is changed.
Change, huh?
Again. Yeah.
Yes.
Yes, we can see the second one, sir, now.
Yes.
Please continue.
Yes. So hydrogen, so because of the diminishing of fossil fuels, people are depending upon alternative energy sources. So among alternative energy sources, hydrogen is also one fuel. So we can see recent newspaper clippings, petrol and diesel prices are hiking because of the diminishing of fossil fuels. And we can also see this image. See, he is Nitin Gadkari, Union Transport Minister, came to Parliament with hydrogen car. That means he is using they are using hydrogen as fuel here. Okay. And also yesterday in Professor Govardhan Mehta mentioned that hydrogen is required for zero emission fuel source. Okay. So here in my presentation, I'm using this hydrogen hydrate hydrogen source, and we are using this catalyst. So actually we have prepared this palladium SbSeOH catalyst. This we are using as the catalyst for the conversion of nitroarenes to aminoarenes. So this is the catalyst we are using. When you add a catalytic amount of palladium SbSeOH to this.
Sir, we are still on the second slide, sir. It has not moved.
So here moving on, my system slides are moving.
No, here it is only second slide, sir, right now. Yes, you can share again.
Now slides are moving now.
Second slide, sir.
Not moving. Third, next one.
It's not changing.
No, sir, it's not changing. We are still on the second slide.
Some slides are changing.
Yes, sir. Now we have the fourth slide.
Okay.
Yes, now now it is changing, sir.
Yes. Sorry, I want to show some images. So I'm directly going to my yeah. So this is the graphical representation of my work, ma'am. So this is catalytic growth. We are mentioning this as catalytic growth, right? Because here we are using this palladium SbSCOH as catalyst for the conversion of nitrobenzenes to aromatic amines. Okay. So here we are using hydrogen hydrate as hydrogen source. So here hydrogen is initially produced. Okay. When you add a catalytic amount of this catalyst, so it is selectively producing hydrogen gas, and also nitrogen is the byproduct. Okay. So this hydrogen we are using for the conversion of this aromatic nitro compounds. This is our catalyst. Here we have synthesized this catalyst. Okay. So in this work, we have chosen SbA15. This SbA15 is the mesoporous silica material. The advantage of the silica material is high thermal stability and high surface area, tunable uniform pores, and tunable surface hydroxyl groups. So this SbA15 support was synthesized by using hydrothermal method, and after preparation of this SbA15 support, we have modified with some organic moieties. Like we functionalized this SbA15 with carboxylic functional groups, and then we incorporated palladium nanoparticles on that. Okay. So here these prepared palladium nanocatalysts. This is mentioned as PDNPS SbSCOH. These catalysts are characterized by several techniques like XRD. See here the first image is XRD pattern. Instead of the image, we can see the low angle pattern of the catalyst. Okay. And after preparation of this palladium nanoparticles, the support hexagonal structure is remained after synthesis of the palladium nanoparticles also. We can see the wide angle XRD pattern in the image. Okay. And some characterization techniques like the nitrogen adsorption desorption isotones here showing. So these are the H1 hysteresis loops are characteristics of hexagonal structure of SbA15. And we can see the SbA15 surface area and prepared catalyst surface area. So we can see the decrease in surface area and pore volume after incorporation of palladium nanoparticles. That is because of the pore blockage. And here I'm showing this TEM image, one TEM image I'm showing. So we can see the palladium nanoparticles are highly dispersed.
Excuse me, sir, kindly try to conclude,
yeah,
sir.
Just a minute. Yes. Highly dispersed in the pore channels of SbA15. So this catalyst we used for the hydrogenation of nitrobenzene to aniline. So these are the some results. So this catalyst we can use up to 5 repeated cycles without loss of any activity. And this is the advantage of this catalytic system is we can use this at room temperature in aqueous medium. So selectively we can produce hydrogen. That is the advantage of this catalytic system. So we can use this for other applications also. Here we have chosen a small molecule, that is nitrobenzene hydrogenation. So there is a wide scope for this catalytic system for this application. So I'd like to thank the principal JBIT and Dr. B. David Raju, senior principal scientist, and Dr. K.S. Ramarao, senior principal scientist, IICT, and organizing committee, CASD 2022. Thank you.
Thank you, sir. Any questions from the audience?
I would like to ask Saidulu, sir. This is very interesting work that you are doing. I think most of your work you're doing at IICT, sir.
Yes, ma'am. I'm depending on IICT because in our institute there are some facilities.
Okay. So only this nitration reaction you have tried, or any other reactions you have applied, sir?
Only this. Yeah, we are using some other. Now we are using them. Actually, this nitration reaction only we have taken as reaction, standard reaction. So we are applying for some other substrates also now.
Okay. You mean like alkenes? Did you try for alkenes and other reactions, sir? Because you have tried for the aromatic, right?
Yes, ma'am. Alkenes, actually, we have published recently one paper, ma'am, on selective hydrogen, chemoselective hydrogenation by using not hydrogen hydrate as hydrogen source. Molecular hydrogen we used as hydrogen source. At room temperature in aqueous medium, we used that, ma'am. For alkenes, alpha beta unsaturated compound, we used the palladium nanoparticles.
Okay, okay. All right, sir. Good work.
Okay, thank you.
Yeah, thank you, Mr. Saidulu, sir.
Thank you.
Yeah, now the next participant, oral presenter 58, Soumya.
Yes, ma'am, I'm presenting.
Yeah, are you there, Soumya ma'am?
Ma'am, am I audible?
Yeah, yes, ma'am.
I'm sharing my screen.
Yeah, please share this. Yes, ma'am.
Are the slides moving?
Yes, ma'am.
So,
Can you
good
please on
morning.
your video, ma'am? Can you please on your video?
Yes, ma'am.
We would like to see who is presenting.
So just a minute, I want to set my camera it's aside.
Soumya, are you there?
Yes, ma'am. Yes, ma'am. I'm adjusting my camera.
Yeah, while presenting, you can do that.
Okay. Okay. Am I visible now?
Yes, yes.
Okay.
Please start.
Okay. Good morning, everyone. I'm Chivukula Soumya. Here I'm going to present on identification of new lead molecules against the SWN protein for the cancer therapy. So cancer is the leading cause of death. When we look into the other diseases, first we need to know the significance of the SWN protein. So this protein, it activates the DNA PKCS complex in the DNA repair mechanism via the non-homologous end joining. When we inhibit this enzyme, previous studies reveal that when we inhibit this enzyme, it actually leads to the apoptosis of the cancerous cell. And this enzyme, this protein is specifically present in the glioblastoma cancer tumor cells. And it is a significant target to treat patients with glioblastoma. And previous studies reveal that SWN protein knockdown will ultimately lead to increase in the radiation therapy to the cancer patients, especially in the glioblastoma patients. So coming to the methodology, the first step is the sequence retrieval. The sequence is retrieved from the UniProt server. The SWN protein sequence, FASTA sequence is then pasted in the BLAST. From there, we select a template. The template, the protein is selected as a template whose query coverage and percentage identity is more than 60%. And then after, further, the amino acids sequence of the protein and the template are aligned using the Cluster Omega web server. The results are then visualized using the BioVia software. The identical residues are seen in green, the similar residues in red, weak is similar in purple, and the similar residues are seen in white. The next step is the generation of the 3D model of the SWN protein. The model is generated using the modular 10.2 software. Actually, we have given the command to generate 100 models, among which the model with least energy conformation is chosen as a model of choice. And this picture is visualized using the PyMol software. The helices are represented in cyan, beta sheets in pink, and loops in orange. Then the next step is the validation of the model generated. Here the save server and the prosa web servers are used. From the save server, the Ramachandran plot is given. From the Ramachandran plot, it reveals that more than 90% of the amino acid falls in the allowed region of the Ramachandran plot, which tells that the quality of the protein is good. And then coming into the PROSA analysis, it gives two plots. One is the energy profile plot and other is the Z-score graph. In the energy profile graph, maximum of the amino acid fall in the negative region of the energy, and then the Z-score graph, the Z-score graph value of the model was given as minus 7.99. More the negative value, more the quality of the protein is. And this minus 7.99 value falls in the NMR and X-ray region of the previously identified amino acid length of that of SW1 protein. And this tells that the model generated is a good model. And then later we come to the active site prediction. In the online servers such as the CASP, FT site, and the Galaxy servers are used to predict the active site by combining the literature, previous studies made on the SW1 protein and the results we got from the active site prediction from the online servers. It is predicted that 52 to 265 amino acid residues length is a active site for the SW1 protein. And then
you can conclude the session.
Yes,
One more minute time is there.
Okay, thank you. Then the area which is selected as the active site is chosen for the generation of the grid and the docking studies. In the docking studies, the selected ligands, especially the phytochemical plants, which is having the property of stopping the cancer, is chosen as a ligand, and it is docked against the SW1 protein. And here are the four highest docked molecules. And the molecule which is having the least binding affinity is chosen as a effective drug against the SW1 protein. So here is the table. From the table, we can see that arginine 117, lysine 144, glutamine 183 amino acids which are hydrogen bonded with the SW1 protein are commonly seen sites. So from this we can predict that these are the active site residues. And the ligands we can see here, this is the common moiety seen among all the ligands, and we can conclude that withanoid moiety, which is this moiety, is an excellent pharmacophore to act against the SW1 protein. Thank you, ma'am. And I thanks everyone for their patience to listening to my presentation. I thank Dr. M. Vasavi for her supervision, and I thank the organizers and the conveyors of the program. And finally, I want to thank the head of the Department of Chemistry, Osmania University, to permit my work. Thank you.
Thank you, Soumya. Yeah, any questions, ma'am?
When did you register, ma'am? Soumya?
Ma'am, I actually came with my interest to do on this project.
That's okay, but not yet registered, huh?
No, ma'am.
Oh, good. That's what I can make out. Okay, all the best. Good work.
Thank you, ma'am.
Yeah, shall I call next participant, ma'am? Any questions? Yeah, next participant. Yeah, OP 59, Dr. Rupasri ma'am from University College of Arts. Good morning, ma'am.
Good morning, ma'am. Am I audible?
Yeah, ma'am.
Yeah, I'll just share my screen.
Please.
Yeah, is my screen visible?
Yes, ma'am.
Yeah. So good morning to all the organizers, conveners, and the jury. I'm Dr. Rupashri Mukhopadhyay, an assistant professor of biotechnology, and I'm here to present a preliminary work done by my MSc Biotechnology students, which entitles Qualitative Analysis and Antimicrobial Activity of the Weed Rivina humilis, which is also known as bloodberry weed commonly. Yeah, to start with, I'm introducing this Rivina humilis, which is commonly known as bloodberry weed. And this is seen growing in the campus of University College of Women very abundantly. So we chose this weed because this is an herbaceous perennial weed with very bright, colorful, shiny berries, and which is very attractive when used as an ornamental plant. And also the berries are seen to be a source for natural dyes. And this wheat has been traditionally used as herbal medicine to treat colds, diarrhea, difficult urination, flatulence, and many other diseases. However, this has not been scientifically used in any of the herbal medication yet. So this created an interest in venturing into this wheat. So then our experiment was aimed at qualitatively analyzing this particular bloodberry weed for the presence of various secondary metabolites which can serve as phytochemicals. And we also wanted to investigate any antimicrobial properties of the plant extract which might be present in this particular weed, because this is very easily available. So it may be treated as an alternative to the regular chemical medication. So the materials which we used was the leaves of this particular weed, Rivina humilis, and we used 2 organic solvents for extraction, particular phytochemical and ethyl alcohol. And we also isolated 2 pathogenic microorganisms, Staphylococcus from bacterial species and Aspergillus niger from a fungal species, to conduct our antimicrobial studies. So we collected the plant tissues, dried them, processed them, and then made it into a powder. And then we extracted the phytochemicals using 2 different solvents here, chloroform and ethyl alcohol. And we also calculated the percentage extraction yield. And we saw that using ethyl alcohol, we got about 13% of the yield of the phytochemical, whereas chloroform yielded only a meager amount of 1 to 2%, which needs to be worked on. So then we utilized this plant extract to qualitatively analyze the presence of 2 very eminent secondary metabolites which function for the use of this product as a herbal medicine. So when we conducted tests for terpenoids, there was this presence of terpenoids seen in the ethanol extract, which formed a reddish brown precipitate using sulfuric acid, while in both the samples, flavonoids were seen to be absent. We also conducted antimicrobial assay using Staphylococcus and Aspergillus. And as you can see in this particular well diffusion assay, which we conducted using Aspergillus niger in figure 6, we found that there was a zone of inhibition which indicated that there is an antifungal activity of this particular plant extract against Aspergillus niger. And this was in comparison with an already reported work on this particular Rivina humilis plant extract against Aspergillus oryzae. So we wish to conduct our studies more on this particular ground and find out more of antimicrobial work in all the other pathogenic bacteria and fungi as well. So this was the finding of our study. So what was the outcome of our experiment was we found a certain terpenoids which were having medicinal value in our ethanol extract. We also found antifungal activity, and which was comparable to other reports. And further characterization using GCMS, FTIR, etc. can give us more idea about the various compounds and phytochemicals which might be present in this plant extract. And also this would enable us to develop novel drugs which may be low cost, high efficiency drugs. And these can be an alternative to the drugs which are already, the bacteria have got resistant to. So this is the finding of our experiment. And of course, this was just a preliminary study. So we intend to proceed this work more and to a higher level. So with this, I thank the principal and the coordinators for allowing me to present this work. And special thanks to Dr. Sushma, who enabled us to identify this weed in the campus, and Istuba, who helped me in preparing these slides. And of course, my strength, Jyoti, Amina, and Rohini, without whom I cannot proceed any work in the department. And my enthusiastic students who are ever ready to venture into any work given to them. So thanks to everyone, and special thanks, special mention to Vijayalakshmi ma'am. Actually, I would like to just mention that we initiated this work because I'm a staunch biotechnologist and I work with molecular markers and other things related to DNA. But this conception of this experiment came when Vijayalakshmi ma'am announced about this international conference, and she motivated me to initiate this work with the students. And within a period of 20 days, my students have come up with such beautiful results. So we are intending to proceed with this work even in future and bring it to a next level. Thank you. Thank you so much.
Thank you, ma'am. Any questions, ma'am?
Good work, Rupashri madam. Your students also put in a lot of efforts. Congratulations on that, ma'am. Now, in a very short period, you have done excellent work. I wish you all the best, ma'am. Please continue good work, good research work. All the best, ma'am.
Thank you.
Okay, ma'am. Thank you very much. Now, the oral presenter 64, Ramya, she wants to present. She has some meeting, it seems. She wants to present before, ma'am.
Hope I'm visible and you're able to hear me.
Yes, ma'am.
Okay, let me share my screen. Just a minute. Is my screen visible?
Yeah. Yes, ma'am.
A very good morning, maybe good afternoon to people who are joining me on this conference. I am Ramya from St. Anne's College for Women. I am faculty from Department of Chemistry. I'm presenting this work, which is a collaborative work with 3 years of BSc students who have worked with me for this. And I am also presenting this work along with my 2 other colleagues, Mrs. K. Vasavi and Mrs. Anita. First, let us, we all know this, that water quality in the lakes of Hyderabad, which once used to be the lifeline for people in the city, is very, very bad currently. So this reports just reflect the current state of water quality in Hyderabad lakes. But you might ask me, what is so novel in this? We are not, the main goal of our work was not just to test the water quality, but also to include the different chemical practices what students learn throughout their 3 years of degree. For example, they learn electroanalytical techniques, for example, conductometry, they learn pH metry using a glass electrode, they learn different titrimetric procedures, redox, complexometric. So when we were thinking of how to involve these works, what students do in their routine lab, to the real world problem, so we came up with this project of testing the different parameters which indicate the water quality of different lakes of Hyderabad. So we would like to assess the water quality of major lakes of Hyderabad. So what were the objectives? As I mentioned, we wanted to integrate different chemical practices in the routine lab, what students do, use those practices to find out the water qualities of different lakes of Hyderabad. We wanted to introduce students to different water testing procedures. We wanted to integrate the routine lab techniques to real world problems. We would like students to understand the real world problems and environment being severely degraded and there can be nothing better than testing the water quality of major lakes of Hyderabad. We are also introducing students to project solving method, problem solving method, and also enhanced lab skills. So we chose the Center for Pollution Control Board protocol, which is general, which is followed throughout India. We followed those procedures to calculate few parameters which indicate the water quality of lakes of Hyderabad. Which lakes did we choose? These were the lakes which were accessible to students. Water was accessible. So we chose water samples from Aminpur Lake, Patancheru Lake, Jirimetla Lake, Sarur Nagar Lake, and Himayat Sagar. So these were the different water quality parameters which we found out through our routine lab. Though they were in different semesters. For example, in semester 3, they were doing titrations, and in semester 5, they were doing electroanalytical techniques. So what are the different quality parameters which we tested using water samples? One was pH, using the pH metry. A is Aminpur Lake, H is Himayat Sagar, Jirimetla, Patancheru Lake, and Sarur Nagar Lake. And below you find the BIS standards, what is permissible. So these pH students did using the regular pH metry. You can see that all of the water lake samples pH is between 7.5 to 8. Permissible is also the same, but this doesn't mean the water water quality is acceptable. Look at the electrical conductivity. Aminpur Lake was fine, but coming to Jirimetla, Patancheru, Sarunagar Lake, the conductivity of water was extremely high. So this suggests that there's a lot of pollution content. Then coming to turbidimetry, we have a turbidimeter, so we could use turbidimeter and we could find out the turbidimetry. Then TDS, we generally use conductometers to do several conductometric titrations. So what we did here is we just changed the mode and found out the TDS. We can
Yeah, some technical problems.
When we saw. Then coming to the total hardness, this is yet another experiment which we do in semester 3. Total hardness using complexometric titration. This we chose the water lakes, water from these lakes, and we could do the total hardness. Again, you can see the total hardness of the 3rd, 4th, and 5th is extremely high. Then coming to, am I audible?
Yes, ma'am.
Okay.
Please conclude
my
the
screen
session. 1 minute time.
Yes. Yeah. The last is with respect to the dissolved oxygen. We did dissolved oxygen through the Winkler method. BOD also was done, and CP also was done using potassium dichromate method. And we also were able to find out the oil and grease current through the partition method, partition gravimetric method. So as you saw,
the screen is not visible, Mrs. Ramya. Your slides are not visible. We are not able to see your slides.
Can you see now?
Yeah.
There was a problem. Yeah, I think now it's visible. So these parameters we were able to find out and assess the water quality through regular lab course. And we can see that the Himayat Sagar water lake quality is acceptable, and followed by Aminpur Lake.
You're not audible, Ramya.
Aminpur Lake and Himayat Sagar Lake water quality is acceptable, but the remaining all lakes are dead. These come under the category E of water sources, and they are unfit for propagation of wildlife and fisheries for irrigation based on the BOD values, what we found out. So this method we were able to do through the 2 years, and this has helped students also to understand the environmental problems, what is around us, through the simple techniques what we do in the lab. Thank you very much for giving me an opportunity.
Thank you, ma'am. Now the session is open for the questions. Any questions, Vijayalakshmi ma'am? Any questions from the participants?
So if there are no questions, I think we can move to the next presenter. Thank you so much, Mrs. Ramya. You can
Yeah.
stop sharing.
Thank you so much.
Yeah, the next presenter is OP60, Malaya Jelle. Yeah, Mr. Malaya Jelle, OP60.
Yes, ma'am.
Yeah. Yeah, please start presenting, sir.
I'm sharing PPT. Is it visible, ma'am?
Yeah, yes.
PPT?
PPT is not visible, sir. We can. Yeah, now it is visible.
Okay. Good morning, one and all. We are three authors, Dr. Damodar Sripati and Department of Chemistry, Lalana Devi, Department of Chemistry, UCW Koti, and myself, Dr. Malaya Jelle, Department of Economics, UCW Koti. Our title of the paper is Impact of Clean Energy on Economic Growth and Empirical Investigation. So, to investigate the impact of clean energy on economic growth in India, for that we have collected the observations, particularly yearly observations for economic growth, clean energy consumption, capital and labor. We have considered the data period from 1990 to 2014. Here the measurement of economic growth, GDP constant prices of 2010 US dollar for clean energy consumption, alternative and nuclear energy as a percentage of total energy use. We have considered for capital, we have taken proxy as a gross fixed capital formation, constant prices of local currency in terms of millions. And another one is labor, measured as labor force in millions. Here we have used econometric model. E.g., the left side one is endogenous variable and the right side of the clean energy, capital and labor force are exogenous variables we have considered in the model. And it is error curve. And beta 0, beta 1, beta 2, beta 3 are the respective parameters for our study. The study starts with descriptive statistics and correlation we have used. Along with these two, we have employed Johnson co-integration and pairwise Granger causality test, where the Johnson co-integration test particularly used for the identify the long run relationship among the variables in the long run, and pairwise Granger causality test we can observe whether the variable is impacting on the other variable or not. We can identify from the Granger causality test. We can conclude from the following hypothesis, growth hypothesis. Growth hypothesis is nothing but there is a unidirectional causality from clean energy to economic growth. It is, we can say that it is positive direction from clean energy consumption to economic growth. And conservation hypothesis, it is unidirectional causality from economic growth to clean energy, opposite direction this one is. And feedback hypothesis, we call it as bidirectional, both clean energy consumption is causing economic growth and economic growth is causing clean energy consumption. We call it as feedback hypothesis. And neutrality hypothesis, absence of causality or no direction between the variables. From the descriptive statistics, we can observe mean is positive for the all the variables, and the correlation from the variables we can observe clearly from clean energy consumption, capital and labor. See, the labor is the highest influencing on GDP and later capital and clean. Overall, we can say that there is a positive highly association between the GDP and clean energy consumption and capital and labor. This is another technique as I said, Johansen co-integration technique. Particularly, it is using for whether the variables are having long-run equilibrium relationship or not. We can identify. These are non-indicating that the trace value for the maximum eigenvalue statistics and trace statistics at none. We cannot reject null hypothesis because trace value is greater than the critical value. We cannot reject, but when we observe at most one, trace value is less than the critical value. So we can reject the null hypothesis and accept that there is a long run association among the variables in the long run. This is a pairwise Granger causality test. The null hypothesis, GDP does not Granger cause clean energy consumption. We cannot reject. But when we comes to the second one, clean energy does not Granger cause GDP, is we are rejecting it and accepting that there is a high impact on economic growth because it is significant at less than 5% level of significance. Okay. From our results, we can conclude that there is a long run association among the variables. We have used clean energy consumption, capital and labor. Why we have used capital and labor means these are the traditional factors which influence economic growth, or we can also say that these two are the control variables. So the results will be, if we include two or more variables, results will be more appropriate than the using of two variables. That is why we used 4 variables. From the conclusion of our paper, the policy implications, particularly when we observe energy, clean energy consumption is favorable for economic growth because it is positive impacting on economic growth. Meanwhile, on the other hand, it is important to note that it is reducing the CO2 emission. Okay, directly or indirectly, it is protecting our environment. So it is better to invest more on clean energy rather than using of fuel, energy, or non-renewable sources. Thank you, one and all.
Thank you, sir. Yeah, any questions from audience, sir? From the participants, sir, ma'am?
Dr. Malaya, have you published this work, sir?
No, ma'am. Recently, I did this paper for only for the conference.
So if you want to publish, what kind of journals would you go for this kind of work, sir? What kind of journals would you choose?
UGC?
Yes, I mean, related to what subject, sir?
Sustainable energy, we can include, ma'am.
Okay. And how does a chemist support you in this work, sir? What kind of
Actually, I focused on environmental side. It is clean energy is there. That is why I have written a paper.
Okay, thank you, sir.
Thank you, ma'am.
Thank you, Malaya, sir.
Thank you, ma'am.
Yeah, any other questions, Vijayalakshmi, ma'am? Shall we move on to next participant, Amina?
Yes, yes.
Yes.
OP62.
Yeah, OP61 next participant. Please be ready. Dr. Dandiram Tukaram. Yeah, Dandiram Tukaram, sir.
Dr. Kehar Singh, sir, can you please stop sharing, sir? T. Vani, OP62, oral presenter number 62. Okay, oral presenter number 63, Dr. Mehtab Yasmin.
Yeah, Dr. Mehtab Yasmin.
Yes, I am. Shall I present?
Yes.
Yes, please.
Okay. Good morning to everybody. This is Dr. Mehtab Yasmin from Department of University College for Women. My presentation today is on a medical tree called as moringa, which is commonly called as drumsticks or what is called as shojan in India. It is a native plant of India. So why we are talking about this is it is to make people aware about this superfood, which is packed with a lot of nutraceutical properties. And recent phytochemical and biochemical studies has shown that all parts of the plant are in fact packed with a lot of vitamins, minerals, calcium, protein.
Your voice is not audible, Dr. Mehtab. Dr. Mehtab, your voice is not audible, ma'am. Let's see if she would like to reconnect again.
Yeah, I think.
Any problem, ma'am? Amina, ma'am?
Yes, ma'am. Mehtab just got disconnected, so we are trying to see
Waiting.
if
She already presented, no?
No, ma'am. Mehtab Yasmin just now started. She hasn't
Earlier,
finished.
earlier, others papers. Okay.
So,
Can we call
Another,
the-
should we start with?
Yeah. Let madam join again, rejoin again.
Yeah, she joined. She again joined, ma'am. Just wait.
Okay. Okay.
Sorry for the delay. There was some technical issue.
No problem, ma'am. Please continue.
Shall I continue, ma'am? Shall I continue?
Yeah, you can.
As I was talking about its medicinal value, it's being used from from a small fever to we can also can be used for lifestyle diseases like diabetes, and it has also the property to lower the BP, and in fact for all the infections it can be used. And to my surprise, it is known that as many mothers in India are struggling for the for production of milk, it is known to be a natural galactagogue which can be used to increase the flow of milk in mothers. So this is the best food we can find right now in our present scenario. Now, this plant is very easily can be grown, and it can be grown in any region. If you have, even in your backyard, you can grow it. Okay, in any temperatures or pH condition, it's not a problem to grow this plant, and it is easily can be grown. Now, if we compare its nutritional properties with different fruits and vegetables which we are regularly using, we have found that it has more power, more times, like 4 times more vitamin A in carrot. We think the carrot is the richest source of vitamin A, but it has more, almost 4 times richer in vitamin A. And when it comes to C, which are vitamin C, 7 times more vitamin C is present in the leaves. And if you dry the leaf powder, the content is, in fact, is increasing. Even the calcium, when we take, the leaves contains more calcium when compared to the milk which we are drinking. So, seeing the malnourishment all around the world, especially in underdeveloped countries or developing countries, if we check the global scenario, we can find that almost in all the countries, this plant is available. And it should be promoted, it should be grown so that everybody can get the benefit out of it. If we take our country's position, we know very well that around 100 million people are affected with malnourishment, and mostly the reason is, the poverty comes with malnourishment, and they cannot afford particular leaves, particular fruits or vegetables. So we can recommend this for a national policy for cultivation of this plant on a larger scale, so that even the government can supply this material for the benefit of our citizens. This can also be used in different programs. This plant can be used for different programs for reducing the anemic condition, because this is also a rich source of iron. So women, especially during pregnancy, we can recommend this source as a source of food, and also at the time of lactation. So this nutritional deficiency are affecting the mental performance, intellectual capacities of our Indian children. So we need to work on it so that we can get a better India. So this we are planning to do under Swasth Bharat, so that Samruddh Bharat, everything can be obtained. Our country can become stronger by using such products. So already some of the value-added products are available in the market in the form of soup powder or smoothie, even candies or biscuits, even small drops. These are available in the market, but it is available only to the elite group. What about the poverty-ridden people, which are the largest percentage of our country? So through this project, we are trying to make some value-added products which will be cheaper and available to every citizen of India. That is the aim of our project, which we are working on. And recently, in our college, we have planted almost during the forest day. Our students have planted moringa plants in our campus itself, and now they are aware about its importance. So this is a small step by which we can, aware people around us. But there are certain challenges with this plant. As you can see, this hairy caterpillars growing on the trunk. This is also a photo of our college, which we have seen that they are, when they are attacking the plants, they are almost nuding the plants. Almost all the leaves are vanished when they are attacking, but it is a temporary phase. It can be overcome. So we want to promote the plantation of moringa everywhere. Each one should plant one moringa or drumstick tree. So in the conclusion, I can say that it's not only a superfood rich with nutraceutical, but it can be explored to be made into value-added products, and it can be supplied to each and every citizen of our country, so that our malnutrition problem should be overcome. And I want to declare this as a national vegetable, as we can find as it is enriched in everything. So instead of pumpkin, I wish to call it as a national vegetable. So that is what we are looking for. So some of the references which we have done for reviewing this particular topic. Thank you for giving me opportunity to present this work.
Thank you, Dr. Mehtab. Any questions from the audience?
Oh, ma'am. Ma'am, we can proceed further, I think, ma'am.
Okay, thank you for this very informative presentation, Dr. Mehtab.
All the best, ma'am.
Thank you, ma'am.
All the best, ma'am.
Thank you so much.
Yeah, ma'am.
And thanks a lot, ma'am. Yes, ma'am. One thank ma'am.
There's some audio problem, I think, ma'am.
Yes, ma'am. Mehtab, ma'am, we are not able to hear you.
Amina, ma'am, how many more presentations we have?
Yeah, 3 more are there, ma'am.
3 are left, ma'am.
Okay. Okay, ma'am.
So 4, ma'am, not 4 are left.
Okay, ma'am.
Thank you, ma'am.
Mehtab, ma'am, you can.
Yeah, okay.
Ma'am, you can stop sharing.
Yeah, the next presenter is Narmada Vallakirti. Yeah, OP 65. I think she didn't join.
Okay, so we got Dr. Keher Singh, OP 66.
Yeah, the next presenter, OP 66, Dr. Keher Singh.
Yes, ma'am.
Yeah, please
Sir,
start.
you can share your slides, sir.
Okay.
So you can start sharing your slides.
Yes, ma'am. We share new remit try.
Sir, kindly start sharing your screen, sir.
Thank you, ma'am. Good morning, all. I am going to present my paper on use of hydrogen as a source of clean energy. I, Dr. Keher Singh, along with Mrs. Rajkumari, both assistant professor in chemistry, GDC, Basoli, and GCW, Kathua, J&K. Hydrogen is mostly used in crude oil refining, production of ammonia, methanol synthesis. For such processes, pure hydrogen requirement is 75% along with mixed hydrogen. 95% of pure hydrogen is obtained from fossil fuels, coal, natural gas, and 5% got through electrolysis. Gray hydrogen produced from methane or by use of fossil fuels is not sustainable way to hydrogen production because it produces carbon dioxide. The main research part where today we are and all the world are with green hydrogen technology. There are three types of gray hydrogen, blue hydrogen, and green hydrogen. The main research part is green hydrogen technology. It is very important because it does not produce greenhouse gas. There is no emission of carbon dioxide. First of all, I will tell what gray hydrogen, it is produced from natural gas. So it emits carbon dioxide. Blue hydrogen, it is split natural gas into hydrogen and carbon dioxide. It also produces carbon dioxide. And green hydrogen, it is the only part where there is no emission of greenhouse gas. So it is the area of future technology or future fuel alternative, so our alternative source of fuel in next future. Turquoise hydrogen production involves the use of fossil fuels. What a good point in this process. It does not involve carbon dioxide production. Green hydrogen produced from renewable source by means of electrolysis process is the cheapest and safest way of hydrogen production, as no carbon dioxide emission is happened in this case. Hydrogen when mixed with air is used to increase. Next we are the fuel is this fuel is used in cars also. Photoelectrochemical hydrogen production helps in production of clean energy, hydrogen, electricity, heat, and industrial chemicals from impure water. Why? Next, hydrogen is considered as an alternative fuel under the energy policy of 1992. About 2.2 of hydrogen gas is equal to 6.2 pounds of gasoline, means 1 gallon, and should take place of it. It is zero emission fuel. Thank you for giving me an opportunity to presenting this in.
Thank you, sir. Any questions from the audience? Pardon, any questions from the audience? So there are no questions. Thank you, sir.
Thank you, ma'am.
Next, I would like to ask oral presenter number 53, Priyal, to please share her slide. She's not available. I think. Oral presenter 53D, Dr. B. Naveen. Okay, oral presenter number 67, Madhu. Oral presenter number 67, Madhu, please. You can start sharing your slides.
Okay. I am audible to you.
Yes, sir. You are audible. You are audible, sir. And we can see the slides also, sir. You can shift to full screen, sir. Sir, please proceed, sir. You are audible, and we can see the full. We can see the slides.
Okay, thank you, ma'am. Very good afternoon, ma'am. Thanks for giving opportunity in international seminar. My title is our presentation title is how to induce the synthesis of N-substituted 1,8-naphthalide, benzamide, and their biological activity, ma'am. The introduction part is the naphthalines are very biological active compounds. Those derivatives are attracted to considerable attention in the appearance of many biological compound skeleton. And construction with 1/8 naphthalene moiety, they give very good biological activities in antibacterial activity and antifungal activity. The reaction is 1/8 naphthalene 2-amine moieties react with aryl benzoic acids. The substituted aryl benzoic acid in presence of R2 gives amide bond esters. The R2 structure is, the reaction starts with the arylic acid. The arylic acid react with R2 in presence of triethylamine in conventional method. It gives active ester. The active ester react with 2-amine pyridine. In room temperature, this gives our compound. The two moieties, the one moiety will react with 5 different aryl benzoic acids. One is 3-chloro and 2-chloro, 5-nitro and 3-trifluoromethyl. Another one is normal benzoic acid. So those compounds which gives good biological activity, which are 3AB and 3BI1 and 3,2. In conclusion, all these compounds gives very good biological activity. In this 3AB and 3P2 and 3B3, so 3B2 is more inhibition activity, highest inhibition activity with Escherichia coli and Aspergillus niger. The molecular structure of these compounds were confirmed by H1NMR and C13NMR mass spectral data, and as well as elemental studies also. Okay, ma'am, thanks.
Thank you, sir. Any questions from the audience? Okay, so this is the last call for OP53 Priyal. Thank you, sir. You can stop sharing, sir. Last call for OP53 Priyal. OP53D, Dr. Naveen. OP65, Narmada. OP62, T. Vani. Okay. Okay, then we will conclude this session. I would like to start by thanking all the participants for sharing such good information with each other and with us. And I would also like to thank the evaluator for this session, Professor Girija Madam, and also our head of the department, Dr. G. Vijayalakshmi, and my colleague, Dr. Narmada, with whose support we were able to smoothly conduct this session. I request all the participants to kindly join the program which is going on, and we will share the link for the program also in the group so that you can join, and please do attend the valedictory session where we will be announcing the winners of the technical session. Ma'am, would you like to say something?
Yeah. Thank you, Amina, ma'am. So as we come to the end of the presentations by the Group C oral presenters, I thank all the participants Thank you one and all for joining us in this conference, for being a very significant part of this conference through the technical sessions. And you have timely responded to the conference by your registrations and for your confirmation through mails and so thank you so much, dear participants. And hopefully we will collaborate in future also on various academic platforms. And at this point, I would like to thank our evaluator, Professor Girija ma'am, who is professor from Department of Chemistry, Palamuru University, Telangana State. And I also thank my friends and colleagues from the department, Amina madam and Narmada madam, who are the session coordinators for the Group C. Thank you so much, madams, for your coordinated efforts and making run this show for the Group C presentations very, very smoothly. So thank you both of you. And also I thank the entire organizing committee for coming up with this great conference. Thank you one and all. So now let us all of us get back to our previous Zoom link. The main programs, there is a session still going on. 4th invited lecture is going on by Dr. Jayanti Subbalakshmi. I request you all to please kindly join us there for the sessions. Thank you one and all.
Okay, ma'am. Thank you.
Thank you.